Hello everyone and welcome back and welcome to a new architecture pattern which is event driven architecture pattern. So this is one of the architecture pattern which is most commonly used and most popular. Okay, so we'll try to understand it more in depth. Okay, with event driven architecture, first we will try to understand what is event and what is event driven architecture actually means. Okay, so what is event? And first of all, how microservices talks to each other, what is the importance of event in the microservice world. Event is nothing but some kind of, you can say, message which is being sent from one microservice to another microservice, which can expect you to do some action or just receive that message and do the asynchronous processing. Okay, like there are two microservices. One microservice is generating some action, and based on that, that microservice want to send an email. So it want to talk to an email service. Okay, so what first microservice can say is I am creating an event for send email, and that event is not synchronous. That event is asynchronous event, and that asynchronous event will be forwarded to the second microservice. Second microservice will receive that message and will do the appropriate action based on what event contains. Okay, so if we talk about the terms, what is event? Event is nothing but something happened, right? A state or application state has changed. User attribute, user database, user table, user email has been changed. And if user email has been changed, we need to raise an event. So what is the event? Notify user. Somebody credited some amount in your bank. What they do, they are raising an event and sending you the notification. So whenever the state of application is getting changed, we are raising an event. Okay, so event terminology should be clear now. It just notifying the system about the change of the state, right? So if the another microservice is not aware about the change which is happening, we are just sending an event and notifying, okay, the state of the system has changed from X and Y, do this or perform this particular action, and that communication is happening through the events. Okay, there can be different type of communication happens between different microservices, like what all we use to communicate to allow a communication between microservices. If you talk about two independent services, they can talk to each other with the RPC calls. In advanced world, you can call it as a gRPC by Google, or you can send an event from one microservice to another microservice asynchronous way, or you can just make a REST call from one microservice to another. You already have the address of another microservice, make a REST API call where you can hit get, put, post, delete. All these HTTP verbs are available to update, delete, get the resource, right? Like user resource, right? So you can make a HTTP call, get, put, post, delete, patch on that particular resource on another microservice from a first microservice. Or you can raise an event. If you are using the event driven message driven architecture, then your first microservice will raise an event and it will send this asynchronous event to the second microservice. Okay, so these are various type of communication can happen between different microservice. So event driven architecture is an architecture style characterized by the existence of number of relatively independent actors who can communicate through different events. I mean, this is just a theoretical definition. It is nothing but, okay, we will be just raising an event from one microservice to another microservice asynchronously, and that microservice will be dealing with it. Okay. So event driven, why I'm not calling it is a synchronous communication, because event driven architecture is adding the loose coupling between the services where one service is not aware about what is happening in another service. If I talk about the simple example, this is one service which is raising event, okay, and these events are being pushed to SQS queue, Kafka, RabbitMQ, any asynchronous queue system, okay. Then there will be a particular set of consumers which will consume the message coming from the SQS or some kind of a queuing system. It can be RabbitMQ, uh, IBM MQs, Kafka, or anything, right? but we created an event and we send it to SQS. We are not aware about which particular service is going to consume this. So we are trying to achieve a loose coupling between different microservices through the event driven architecture. And it is purely asynchronous because event created, event sent, we get acknowledgement, okay, event sent successfully. Now when this event is getting processed based on the availability of consumers, what is the sequence of the event in which particular fashion that event has been executed? For that you have to use some certain set of constraint on these queues like FIFO queues and all these different patterns. Okay, so what is event driven architecture and what all different primitives? So there are different kind of events we will be handling with, like events, command and queries. How two microservices can talk? Like I can request you some data, I can command you for doing some action. So when I'm saying, when we are using command pattern or command, that means I'm expecting some action from you. When I'm saying query, okay, just give me this data. So all these are actually event driven primitives, events, commands and queries. What are these? We will talk about them. Event notification, event carried, state transfer. Every event when these are getting executed, they actually carry the state transfer. State X will transition to the state Y. Okay, all interactions taking place in distributed system. Distributed system means systems are independent, loosely coupled over the network, can be categorized into three different primitives: events, command and queries. If you understand this event, command and queries, you will be able to understand CQRS and event sourcing patterns. Okay, what is event? Whenever a system perform an action, the message containing that observation of fact, that is called an event. You received an email. Okay, you received an event. You sent an email. It means you raised an event. Okay, what you have done is you performed some action, and that information, that information is contained inside message, that is called as an event. Okay, command, whenever a message carries an expectation of changing the internal state of the system, that is called command. There is some expectation involved whenever we are raising an event. Okay, not, it's a simple message, right? Now we are talking in terms of message. Message can be an event, can be a command, can be a query. Whenever a system is required to retrieve its internal state and present it, query means I'm querying you this data, I'm querying you this particular state, give me. So this will become a query. So this message will be known as a query. Okay, command, when I'm expecting you to change the user state from state X to state Y, that will become command. Okay, so basic terminologies are clear for event driven. Now we are talking about how these notifications happens. We are reaching the event, then there should be always be a one producer, one consumer, right? One service will be raising the event, sending that message to the event store, to some particular queue system. So this is like asynchronous one way communication is happening. You are sending and this is receiving. Because like, consider a real world example, mail notification service. You have created one microservice which is sending email, and another microservice is doing some random task and sending email, sending notification, right? Send raising an event. So that raising event will be one way from that microservice to an event notification microservice, right? And you may be using, because we are calling this asynchronous because these two microservices are not talking to each other. They are considered as a producer consumer services. So we will be just sending this event to the event store and consumer will consume that event and will send the message. Okay, event with state transfer, you will be raising some event which will carry a particular state change in the store, right? So like query request, here this is your application, here you have a local uh, application state. What you are doing is you are making an action, okay, and this action is getting updating, this action indirectly updating this user state in the database, right? So once that is done, event will be emitted and event will be consumed by the local store. Local store will be updated and it will notify the user about this particular change. So there will be some particular event which will carry the state transfer in the system. Okay, just a basic example like how this producer consumer works is, here your event data It can be your front end application, can be a microservice which is raising event. On a front end, you are clicking on to one button, doing a validation, doing verification, then it is raising event. And here is your publisher, maybe another microservice which is taking care of publishing these events, which can be query command, right? It is publishing these events to the event store. Okay, and there will be a subscriber who will be subscribing this event data store to receive what event we have received. That will happen asynchronously. So there is a publisher and there is a subscriber to this event data store. Now you can consider that this is a Node.js microservice, this is your SQS, this is can be your RabbitMQ. You pushed one event and there is another Node.js microservice listening to this RabbitMQ to receive the event which has been delivered to this SQS or RabbitMQ. Then you will just talk to the relevant service to update the system state. Okay, so what are the pros and cons of event driven architecture? The only thing which I see is, what if there are multiple events are coming, and what you want is all those events should execute in a particular sequence, so your final state of the system should be consistent. Okay, you triggered three different events. Okay, read data, update data set 1, update data set 2, or read final data. If this sequence get distorted, then you will have a different system state, and in final query where you are requesting the current system state, you will get the wrong information. Okay, the resilient is difficult to implement a combination of loosely coupled services. Event-driven architecture applying this loose coupling between all services which are associated with this event store. Data consistency and coherence across services can pose a challenge, forcing developers to consider eventual consistency problems such as timeless and collision. Like, we have to take care of the sequence of execution of events which are coming and getting processed. Okay, because sometimes what happens, the sequence of the event matters, and if there is any conflict, okay, particular event is not expected to execute first, then we will not be able to get the consistent data or consistent state. Okay, in that case there are always a pros and cons, and there are always a way to fix it. So we'll talk about that in the next video.